Hello, we're going to run through the Unit 3 answers to the review because I had some students ask for this from last year. So I'm just going to run through the answers so it's a better way for you to see how the problems are done without having to come see me for every little question you have. So we're going to start with the two graphs, and it says on the graphs above, each line represents one unit. Find the following. So if it says f of 1, that means I know x is 1. So I'm going to go on the x-axis at 1, and I go up until I hit my graph, and again, we're on the f graph. And so that value is, I had to go up 1, 2, 3, 4, 5, 6. So that value is 6. F of negative 3 means x is negative 3. So I go on the x-axis to negative 3 up until I hit my graph. That value is 4. Now we go over to g of negative 4. I go over here, 1, 2, 3, 4. I go up, and that's positive 4. And g of 3, 1, 2, 3, 1, 2, 3, 4. I had to go up 5. So g of 3 is 5. Right? The last two questions ask us, when does f of x equal 5? We no longer know what x is. We know that y is 5. So we go on the y-axis at 5. 1, 2. And I draw a line. And it hits my graph twice. It looks like it hits it. I'm going to call that negative 1. I think I meant to put that negative 1. It could be negative 0.7 if you wanted. Okay, it looks like it hits it around negative 1. And the second x value is 1, 2, 3, 4. So you get two answers for that one. The last one says, when does g of x equal 3? So I go on the g of x graph, and we really mean that y is 3. So I go on the y-axis at 3. 1, 2, 3. I draw my line in. It hits our graph 2 times, and those two values are 1 and negative 3. So I get two answers. Right now we're going to use the same two graphs for composition of functions. You always start on the inside. So I have g of negative 1. That's where I'm starting. So I go on the g graph over here to negative 1. The value is 1. What that means is I'm really finding f of 1 because g of negative 1 is equivalent to 1. So now I go on the f graph and I go to 1 and I count up. 1, 2, 3, 4, 5, 6. So that means f of g of 1 is equal to 6. Okay, the second one, I'm going to find g of 3 first. I start with the inside. So I go over to 3, I go up 1, 2, 3, 4, 5. G of 3 is equivalent to 5. So what I'm really finding the second time around is f of 5. So I go over 1, 2, 3, 4, 5. Up 1, 2, 3, 4. All right, f of g of 1. Again, we're going on the g-axis first, or the g graph first. So I go to 1 on the g graph, and I get a value of 3. G of 1 is 3. So I'm really finding f of 3 now. So I go over here to the f graph, go over 3, and I go up 3, 4, 5. And it looks like about 5.5. All right, moving on to the bottom. Now I switched it up on you. I said we're going to start with f first. So f of negative 1. I go on the f graph first. Let me just erase what I have here. So I go to negative 1, and I go up 1, 2, 3, 4. We'll call that 5. Okay, so f of negative 1 is really 5. So now I go on the g graph, and I'm really finding g of 5 now. 1, 2, 3, 4, 5. Gotta scroll up. 1, 2, 3, 4, 5, 6, 7. Right, now I'm going to f of 6. I go on the f graph at 6. 1, 2, 3, 4, 5, 6. That value's 3. So really what I'm finding is g of 3. And g of 3 equals 1, 2, 3, 1, 2, 5. Right, I'm going to skip the next couple because of the next one because it's the same. We're going to move on to the f of negative 3. Now this means I'm going to the f graph twice. So I go up to negative 3 here. So that means f of negative 3 is 4. So what I really want to do the second time is find f of 4, which is 5. All right, the second one is the same thing, except now I'm going to the g graph twice. So I'm going to first find the inside, which is g of negative 4. So 1, 2, 3, 4, 1, 2, 3, 4. And g of negative 4 is 4. So the second time around, I'm going to go to g of 4. And that's 6. Right, and the last one is the same thing, except now I have to do it 3 times. I start with f of 4. And that's 5. So next step, I go to f of 5. And that's 4. So I'm working my way out. Now I finally get to the last layer, which I'm really finding f of 4. And that's 5. So I had to go to the graph 3 times to get my final answer. All right, the last question on this page just asks, explain why f and g are functions, and all you should be talking about is the vertical line test. So if I take a vertical line here, this one passes the vertical line test, and this one passes the vertical line test. So explain why they're functions. My simple explanation would be they pass the vertical line test, VLT. Okay? All right, the next 2 examples are a little bit tricky, and once you get the hang of it, they're easy. It says, draw an example of a graph, table, and mapping that represent a function and explain why. So simple way to draw a graph. That graph is a function, again, for the same reason, because it passes the vertical line test. Right, a table we learned is each x. The definition of a function is that each x has at most 1 y. Okay, so that means that none of my x's can repeat in the table, but it does not matter if the y's repeat. So this is a function because each x has only 1 y. Or in other words, the x's don't repeat. Right, and the last one's the one that you're least familiar with. It's a mapping. So I could take this table here and put it in a mapping. So I write my x values there, and I write my y values here. And I don't need to repeat the values because I'm going to be drawing arrows. So 1 maps to 4, 2 maps to 3, 3 maps to 4, and 4 maps to 3. Notice each x only has 1 arrow coming from it, so that's why it's a function. So again, it's the same explanation before. Each x has only 1 y. Or in other words, each x has only 1 arrow. It does not matter that the y values have more than 1 arrow because we're only concerned with the x values being unique. Okay, so now these should be pretty easy now. A graph that wouldn't work would be something like this, and all you'd have to say is it does not pass the vertical line test. Okay, a table example we talked about earlier. All you have to do is repeat 1 value in your x's, and those 2 right there do not make this a function. And the reason is because 1 has 2 y values. Because the x value of 1 I should write. X equals 1 has 2 y values. Right, and I'm going to put that same table in a mapping. 1, 2, 3, 4, 3, 2, 1. 1 maps to 4, 2 maps to 3, and 1 also maps to 1. So you see right there is the tricky spot. 1 has 2 arrows, which means, okay, now that's just the simple terms. It really means that 1 has 2 y values, which makes it not a function because the definition is each x has at most 1 y. Okay. Now we get to function notation, and we notice we have notation and composition all at once. So if I want to find f of 4, that means I go to the f of x function, which is 2x plus 1, and I replace x with 4, so I get 8 plus 1, which gives me 9. G of 4, I take the g of x function, which looks like that, and I'm replacing x with 4. Remember, you have to do your exponents first. So you do 3 times 16, which is 48, minus 8 gives me 40. All right. G of negative 2 is similar. Okay, I'm replacing x with negative 2. Now, please don't rely on your calculator to do this. A negative number squared is always a positive. So you get 3 times 4 minus 8. 12 minus 8 gives me an answer of 4. The last one is h of 6. So you have 1 over, really 6 squared because I'm replacing x with 6, which gives me an answer of 1 over 36. Right, the last couple are all compositions. You work your way out. So you have g of 2. You first find that. So you'd write 3 times 2 squared minus 8, which is 12 minus 8, which gives me 4. Since g of 2 is 4, I'm really finding f of 4 because I'm replacing g of 2 with 4. So I go to the f of x function and now plug my new input in, which becomes 8 minus 1, which is 7. Right, the next one I'm starting with f of 2. So f of 2 equals 2 times 2 plus 1, which gives me 5. So f of 2 is the same thing as 5. So the next step is I'm really finding g of 5. So I get 3 times 5 squared minus 8. 5 squared is 25, times 3 is 75, minus 8 gives me 67. H of j of 3 means I'm starting with j of 3 first. J of 3 is simple, it's 6. 2 times 3 is 6. So now I'm really finding h of 6, which we already found in part D, gives me 1 over 36. And the final one for composition here is g of negative 1. Remember, a negative number squared will always turn into a positive. Please do not rely on your calculator. Since g of negative 1 is really negative 5, the second thing I'm finding is j of negative 5, which is 2 times negative 5, which gives me negative 10. Now the next page is very similar, except now I don't have a number to plug in. I have just the expression g of x. So what I do is I take the g of x function, which is 3x squared minus 8, and I plug that in for every single x in the f of x function. So f of x is 2x plus 1. So I replaced the x with g of x, which is 3x squared minus 8. Okay, so the next one I'm doing the opposite. I'm taking f of x and I'm replacing it for every x in g of x. So I'm going to write the g of x function, which is 3x squared minus 8. I'm going to need more space than that. Okay, since f of x is 2x plus 1, that's what I'm replacing x with in g of x. So that's what it looks like. Now, I don't know whether or not your teacher said simplify, but you can try to simplify these. So for example, number 1, I could distribute the 2 to both parts. So that would give me a 6x squared minus 16. That's as simplified as I can get there. Oh, never mind. Take that back. I still have that plus 1. I get 6x squared minus 16 plus 1. So as simplified as I can get is to combine those two, I get a negative 15. The second one's a little bit harder to simplify. Recall that 2x plus 1 squared is really 2x plus 1 times 2x plus 1. And you should remember the terms FOIL or distribute. So you get 4x squared. 2x times 1 is 2x. And then you have to distribute the second one there. So you get 1 times 2x is 2x. 1 times 1 is 1. Combine your middle terms. The 2x plus 1 squared is really equivalent to 4x squared plus 4x plus 1. And I just put that in for the 2x plus 1 squared. Now I distribute the 3. I get 12x squared plus 12x plus 3 minus the 8 on the end. I can combine those last two terms, so I get 12x squared plus 12x minus 5. Now again, you don't have to simplify. I would try it though. If you get to this step, you're fine. Please try to simplify because eventually you're going to need to do that in this class. H of g of x is next. I'm going to rewrite h of x, which is 1 over x squared, except now I'm not going to put x in. I'm going to replace it with what g of x is. And g of x is 3x squared minus 8. I'm not going to bother to FOIL that one out. That's going to take some work. So there's our answer. I can FOIL it out later if you'd like. Right, and the last one take h of x and stick it into g of x. So g of x is 3 x squared minus 8. Now I'm taking h of x and I'm replacing it. So it's 1 over x squared. Now I will simplify this one. I'm going to square both of those first. So it's 1 squared, which is 1. And x squared is x to the 4th. I can multiply the 3 in. It's really 3 over 1, so I multiply the top and I multiply the bottom. I get 3 over x to the 4th minus 8 as my final simplified answer. All right, so I hope compositions are working out. Remember, if you get to the top step, you're fine. If you want to try to simplify, that will be great. Right, now we're on to domain and range. Domain, it's left to right, or max to min, or excuse me, max to min, or minimum to maximum, okay? And it's your x values. So those are the things you should note about domain. Min to max, x values left to right. So the left x value, the farthest to the left looks like it's negative 3. The farthest to the right looks like it's positive 3. So my domain is going to be negative 3 to 3. Range, things you should know about range. Well, if domain is the x values, range is the y values. And if domain's left to right, range must be bottom to the top of the graph. Or it's also min to max. I had a couple of kids flip-flop. They wrote 4 to negative infinity. Well, negative infinity is clearly smaller than 4, so they should have had written that first. So it looks like the bottom of our graph is 1, and the top of our graph is 4. So my range is going to be from 1 to 4. Remember that bracket just means it's included. We never include infinity if it's in our answer, so we use an open parenthesis. Right, the next one, let's keep thinking left to right, okay? Now, I put the little mark there, but that arrow means it goes on forever, so that really doesn't help us. But we have a farthest to the left point, which is negative 3. But the arrow means it goes on forever to infinity, so I have to use infinity in the open parenthesis for the domain. The range, it looks like there's a bottom to this graph. It's 2. But that arrow again signifies it's not only going to go to the right forever, it's also going to be going up forever. So that also goes to infinity. And the last one is a parabola. We talked about this, I know, a couple years ago as well. Parabola, the x values can be anything, so negative infinity to infinity, because those arrows are on both ends, signifying that it goes on from the left forever and to the right forever. And the range, we have a bottom, it's negative 3. But the arrows mean that it's going to go up forever, so this one goes to infinity. To go. All right, 3 slides to go, I think, or maybe 4. I'm feeling a little bit tired at the end of the night, but we're going to finish this bus. Okay, so we have time on the x, speed on the y-axis, and I think for the most part you guys are pretty good at this except for a couple questions. So domain, we know, is our x's, so 0 to 25. And you can write it in interval notation now that you know that. And it says, what does it mean? That's just how long the bus drove. Okay, or in other words, it's just how long they tracked it, because I don't think the bus drove for only 25 seconds, but I think it's how long they tracked the bus's speed. The range is the y values. So the bottom of the graph is 0. That means their minimum speed was 0 and the maximum speed was 10, it looks like. So what does that mean? It means the bus traveled at speeds between 0 and 10. So somewhere between there, the bus was traveling. It didn't get above 10 meters per second, I'm guessing, miles per second. And then it didn't get below 0 because it can't have negative. Continuous or discrete? Well, I can draw this one without picking up my pencil. Remember, discrete is dots, or it's not connected. This is also a discrete graph because you jump. All right, but the graph that we're seeing right here, I could draw this whole thing without picking up my pencil, so it's continuous, and you would have to write y. Well, it's all connected. Or you could write, I can draw it without picking up my pencil. All right, the maximum value is the one I got a lot of questions on today. It's because you don't know really what it's asking. It doesn't want the maximum x, maximum y. Anytime you have a real world from the maximum value is just the top y value. So in this case, it's 10. And that occurred, if it asked you when it occurred, you'd write between 4 and 10 seconds. But it's just asking us what is the maximum value. So the maximum value is 10. And what does it mean? It's the maximum speed the bus got to. All right, so let's finish up these questions here. Which interval is it traveling at the fastest speed and what is its speed? This is where we're really thinking slope. So what does it have the steepest slope? It looks like it's traveling. Oh, never mind. Excuse me. We're not looking at slope because speed is on our axis. Take that back. Fast forward to that last spot. We just talked about the fastest speed. It's 10. So this is the question that says when is it traveling? And you would write between 4 and 10 seconds. And you can write it as a restricted domain, or you could just literally write from 4 to 10 seconds. And the speed is 10 miles per second, or meters per second, excuse me. Right? Find f of 20. What does it mean in the context of the problem? If I go over on the x-axis at 20, it looks like the speed is 4. And that just gave you the context. The speed is 4 at 20 seconds. Oh, and I should write the speed is 4 meters per second. Speed is 4. That doesn't really give me much. Speed is 4 meters per second at 20 seconds. It says find x when f of x is 8. That means I'm going on the y-axis. That means I know the speed is 8. So notice I have two spots when the bus is traveling at a speed of 8 meters per second. It's at 4 seconds and approximately 11 seconds, it looks like. So 4 seconds. And what it means is that the bus was traveling at a speed of 8 meters per second at 4 seconds on its journey and 11 seconds in its journey. Right? Now we're getting into the last thing, which is inverses. Remember, inverse is where you flip the x and the y. So this question should be almost a freebie. If the point 8, negative 4 is on the graph of f of x, what must be on f inverse of x? You just have to switch it. Switch your x and y around, and that's the point that has to be on the inverse. It's the same idea with the rest of these. If g of 4 is 11, which means you have the point 4, 11, that means the other point should be 11, 4. So if I have g inverse of 11, that must have to be 4. Okay, the last one, last couple, you're just going to flip it, 12 and negative 3. And if g of 8 equals 14, then g inverse of 14 has to equal 8. Okay, did I skip? Hold on. Sorry, I skipped number 8 because I realized I didn't have it in my slide, and I'm actually going to skip 8C altogether. The answer on my key is not correct. I didn't finish the problem, so I'm just going to do 8A and 8B. So 8A. First step, whenever you see f of x, I want you to replace it with y. Then second step, switch them. So you get x equals 3y plus 7. Whenever I switch it, just interchange the x and the y. Flip them around. Nothing else should be changed. 3 stays and the 7 stays in the same spot. Now I'm just going to solve for y, so I'm going to subtract 7 first. Get x minus 7 equals 3y. And last step, divide by 3. And you can leave your answer like this. However, I need to use correct notation. So I mean leave your answers, you can just leave the 3 on the bottom. You don't have to separate it out. But we have to write it with the correct notation, which is f inverse of x equals x minus 7 over 3. Right? 8b is now p of x. We're going to change that to a y. So y equals 4 minus 3x. Second step, switch them. X equals 4 minus 3y. Now I'm going to resolve. Minus the 4 from both sides. So I'm left with x minus 4 equals negative 3y. Divide by the negative 3. Left with y equals x minus 4 over negative 3. Again, correct notation would be p inverse of x equals x minus 4 over negative 3. All right, now I can jump to 10 since I already did number 9. The last ones, is inverse as well, except now I have to do a graph. And the easiest way to do a graph is pick your key points. And that, what I mean by that is your endpoints at any point where the graph turns. So I've plotted 3 points, and I need to find the coordinates of those. So this is -7, -2. This is the coordinate 0, 1. And this is the coordinate 4, 1, 2, 3, 4, 5, 6. Okay, when I'm going to do the inverse, I need to plot 3 other points. The points I need to plot are 6, 4, because I'm going to switch the x and the y. Okay, I need to switch the 1 and the 0, so it's going to be 1, 0, and I need to switch the -7 and the -2, so it's going to be -2, 7. Now, all I have to do is plot these points, so I'm going to plot 6, 4. There's my first point. I'm going to plot the point 1, 0, which is right there, and -2, -7, way down there. So my inverse graph looks like that. You can always check it by drawing in the line y equals x, because remember, the inverse is a reflection over the line y equals x. And you can see that that's where the line of symmetry is, so I did it correctly. The last graph looks like this, right? So I have the point -7, 3, and the point 2, 4. So the new points I'm going to graph is 4, 2, and 3, -7. So I go to 4, 2, 3, -7. Oh, that was a really bad line. My inverse looks like this. Okay, and again, check it by just sketching in the line y equals x. That looks like it's the line of symmetry, so I'm done. Domain and range are my last two. Man, it's getting long. All right, so the domain, I go all the way my x's to -7 of the first graph, and my y's go to 4, or my y's, and the ending to the right is 4. The range is bottom to top of the original graph, not the inverse, so ignore the red one. The bottom of the original is -2. The top of the original looks like it's 1, 2, 3, 4, 5, 6. So -2, 2, 6. That's a positive 6. Right, now the beauty of the inverse function is the inverse is when the x's become the y's and the y's become the x's. So I'm going to tell you right now the domain should be -2 to 6. And let's just check. Of the red graph, the domain is -2 is my left, 6 is my right. And the reason for that is you literally just have to flip them around. So the new range is going to be -7 to 4. So I just switch the domain and range for the inverse because remember the x and the y switch. So if I check that, the bottom of my graph is -7, the top of my graph is 4. So once I find the domain of the function, I can quickly find the domain of the inverse function by just flipping my domain and my range. So the domain of the original function, the left point is -7, the right point is 2, so it's -7 to 2. Okay, the range, the bottom is 3, this one's really short, the top is 4. So to find the inverse function's domain, it's the range of the regular function, and the domain and the range of the inverse function is going to be the domain of the original function. So I literally just had to switch those around in order to get the inverse function. You can check. The left point of the blue function is 3, the right point is 4. The bottom is -7, the top is 2. Okay, so I hope this helped a little bit. It's going on forever, and have a good night.